In this video, we will be finding the height, radius, or diameter of cylinders, cones, and spheres when we're given the volume. We've already found the volume when we're given the height and the radius, and now we're going to be looking for the radius or the height when we're actually told the volume to begin with. Make sure you have these formulas in front of you. This video goes along with your notes. It may be in your notebook or it may be separate. If you don't have either, you can always follow along and take notes on separate paper. In our directions, it states to use 3.14 for pi and to round our final answers to the nearest hundredth. Also, we need to remember to label with correct units. For each problem, we're going to include the formula filled in with numbers, and the final answer. You will also be showing work, although you can use a calculator. Let's start with this problem. It says find the height if the volume is 628 inches cubed. The first thing that we need to do is identify what shape we are working with. In this case, we have two circular parallel bases, so we're working with a cylinder, and we're going to write down the formula for volume of a cylinder. I wrote volume equals pi r squared h. Now, we need to look at the v, the r, and the h and figure out which variables we know the value to. We know that our volume is given, it's 628 inches cubed. We know that our radius is given, although we need to do a little bit of work. We see that the diameter is 10 inches, so therefore our radius is 5 inches. And our height, which would be going from the distance between the two parallel bases, is what is unknown, so we will still see an h in our work. Let's fill in what we know. I have 628 equals 3.14 times 5 squared times h. In order to isolate h, I know that I'm going to have to divide by the 3.14 and the 5 squared. I could choose to do this as 628 divided by 3.14 divided again by 5 squared, or I could multiply my 3.14 times my 5 squared, or 25, first, and that's what I'll choose to do. So I get 628 equals 78.5 h, and then I can divide by that coefficient in order to isolate h, and I get 8 equals h. So my answer is that the height is 8 inches. Don't forget that we need units, and since we're dealing in one dimension, our unit is inches, not inches squared like area or inches cubed like volume. Now, of course, we could check this by actually finding the volume. We can do pi r squared h, so 3.14 times 5 squared times 8, and see if we get 628, or we could estimate in our head. 3 times 25 times 8, notice that I took pi and I rounded it to 3. 8 times 25 is 200, times 3 is 600. So I'm in the right ballpark, and I can be pretty confident that I got the right answer. Notice that we included the formula filled in, and our answer. Because we weren't looking for the volume, we had some extra work in between. Although I used a calculator, I still expect you to write out the in-between steps. Here's our next example. Find the height if the volume is 1,406.72 centimeters cubed. As usual, if you think you know how to do it, one strategy would be to pause the video and try it on your own, then press play to see if you did it correctly. The first thing we want to do is identify the shape. We can see that this is a cone because we have one vertex and a circular base. Then we need to write the formula for volume of a cone and identify what dimensions or what information we already know. I copied the formula, volume equals 1/3 pi r squared h, and I wrote my three variables to the side. My volume is given, so I'm going to fill that in. My radius I can figure out because I show a diameter of 16, so therefore my radius is 8, and I'm looking for my height. Let's fill that into the formula, and then we'll be able to solve. I filled in my numbers. Now, this problem's a little different than the other one because if I multiply 1/3 by 3.14 times 64, I end up getting a decimal that is not too friendly. I would get 66.986 repeating, and I would need to divide both sides by that. Now, you can avoid errors by typing in a lot of sixes, but let's look at how we could instead keep our answer exact. Let's leave the 1/3 as is and just multiply the 64 times 3.14. Now, I need to figure out how to get rid of that 1/3. I know that if I had this equation, 1/3 x equals 10, I would simply multiply by 3 in order to get rid of that 1/3. So we're going to do the same thing here. Let's multiply both sides by 3 in order to cancel out the 1/3 so we don't get an obnoxious decimal. That leaves us with this. And now I can divide both sides by 200.96, and I should get a much friendlier answer without a repeating decimal. The answer that you should get is 21 equals h. Therefore, my answer for the height is 21 centimeters. Basically, what I did was I wrote the formula for the volume of a cone, I filled in the values that I knew, and then in order to solve, I multiplied both sides by 3 so that I could clear the 1/3. Then instead of dividing separately by 3.14 and by 64, which I could have done, I multiplied those together first and divided. If I wanted to check my answer, I could plug in 21 for the height and use a radius of 8 and solve for the volume, and I would find that my volume is 1,406.72 centimeters cubed. Did this math problem get you curious about how big that cone is? I decided to look up a cone that I'm familiar with, a party hat, to see approximately how this compares. This says that the dimensions are 5.5 inches by 4 inches. I converted that to centimeters and saw that it was 14 and 10. I don't know which is the height, although I'm assuming it's the 14, and what the 10 is, although I'm assuming it's the diameter. This next problem is a little different from ones we've done. It says find the radius if the volume is 452.16 inches cubed. This may be in your notes depending on which version you have. The first thing we need to do is identify the shape. We have a cone. Then we're going to write the volume formula, so volume equals 1/3 pi r squared h, and identify what we know. We know the volume is 452.16 inches cubed. We don't know the radius, so I'm going to write a question mark, and we know the height is 12 inches. Remember that the height is the distance from the vertex to the base, the perpendicular distance, so notice that that makes a right angle with our circular base. It doesn't matter that we might say that this cone is sideways. Now we're going to fill in what we know to the formula. Now I know that I need to isolate r squared before I can take the square root to find r. Last problem, we saw that in order to get rid of the 1/3, we could multiply each side by 3. We can still do this here, but because we have a 1/3 and a 12, we can see that that 1/3 times 12 is going to give us an integer, so we will not end up with a messy repeating decimal. So we actually could choose to multiply the 1/3 times the 3.14 times the 12 and then divide by that. I'm going to choose to do that here versus on the last problem, since we ended up with a repeating decimal and the 1/3 did not cancel with anything, I chose to multiply both sides by 1/3. 1/3 times 3.14 times 12 is 12.56. This makes sense that it's very close to 12 because our 1/3 and our 3.14 are very close to canceling out with each other. So we are multiplying about 1, but a little bit bigger, by 12. Now we need to divide both sides by the 12.56, and that gives us 36 equals r squared. Now, when we solve for r, we know that we'll take the square root of both sides, and although technically our answer to this equation would be positive and negative 6 equals r, we know that our answer cannot be negative because we are finding the radius, and it would not make sense to have a negative value. So we have that the radius equals 6 inches. Remember that a radius would be inches. Only when we're working in volume would we have inches cubed. We could again check our answer by substituting 6 in for the radius in our volume formula and solving for the volume. For this problem, we identified the shape, we wrote our volume formula, filled in everything we know, which was the volume and the height. Then we solved for r by first multiplying each of our factors, dividing by the coefficient 12.56, and then using the square root. That's what makes this problem new, is that we had to use the square root in order to solve for r, and we found our radius. Here's our next example. Find the diameter if the volume is 113.04 centimeters cubed. We identify that the shape is a sphere, and then we write the formula for volume of a sphere. Volume equals 4/3 pi r cubed. Notice that there is no height here. So we identify what we know. We only have two variables. We know that the volume is 113.04, and we do not know what the radius is. So let's fill that into the formula. 113.04 equals 4/3 times pi times the radius cubed. If we multiply 4/3 times 3.14, we will run into the same problem that we ran into before, where we end up with a repeating decimal. If I gave you this equation, 4/3 x equals 10, you would solve that by dividing by 4/3, in other words, multiplying by the reciprocal, 3/4, on both sides. We're going to do the same thing here. We need to first multiply both sides by 3 in order to cancel out with the 3 in our denominator. The 3 in our denominator is what is causing the repeating decimal, so now that that's gone, we are left with this. I could have chosen to divide by the 4 and then the 3.14, but instead I multiplied those together because there is no denominator, so I will not have any repeating decimal to deal with. Now I need to divide by my coefficient, 12.56, and I am left with 27 equals r cubed. Luckily, I know the cube root of 27. The cube root of 27 is 3. That tells me that my radius is 3. But wait, the problem didn't ask for the radius. The problem said, find the diameter. No big deal. That just means that I need to double my radius. And therefore, my answer is 6 centimeters. 6 centimeters is the diameter of this sphere. If I wanted to check, I would plug my radius, 3, into the volume formula, cube it, multiply it by 5, and times 4, and divide by 3, and I should get the original given volume. My final thought for you is that when you see a problem where there isn't a figure given, and it's given instead in words, make sure that the first thing you do is you draw a diagram. You draw a diagram and you would label the height or the radius or the diameter or whatever is given. You can stop the video here, or you can listen to this final thought. When we're solving, we chose to do this in multiple steps where we multiplied both sides by 3, then multiplied our factors together, and then divided by that. I could also choose to do this in one step. I could multiply 3 to both sides, divide by 4, and divide by 3.14. If you're doing this on a calculator, remember to either use parentheses around your denominator or to type it in as 3 times 113.04 divided by 4 divided by 3.14. Choose whatever method makes the most sense for you, but make sure that you are not rounding in the middle of your problem. So it is important to multiply here in order to get rid of the 3 in the denominator to avoid that repeating decimal. This is similar to simpler problems we've done this year, where we could choose to multiply this together and get the answer, 25, as our coefficient, but we also could choose to multiply both sides by 2 and then divide by 5 and 10, or divide by 50, etc. Lots of options to reach the same answer.